Okay, now this really is the last video. At least I had a chance by splitting these up to get my focus fixed because it was pretty bad yesterday's. So this is the second example on that chapter 24 worksheet. It should go pretty quickly because confidence intervals are always less work. Let's just get right to it. Many drivers of cars that can run on regular gas actually buy premium in the belief that they will get better gas mileage. To test the belief, we use 10 cars in a company fleet in which all the cars can run on regular gas. Each car is filled first with either regular or premium gasoline decided by a coin toss and the mileage recorded for that tank full. Then the mileage is recorded again for the same cars for the tank full of the other type of gasoline. We don't let the drivers know about the experiment. Here are the results in miles per gallon. So, we notice that we have 10 different cars numbered 1 through 10. Those numbers mean nothing other than just identifiers. Okay, so this is when I see this layout, this table, it screams at me these are matched pairs. You're using the same cars and we're doing two different kinds of treatment experiments. We have a 2-treatment experiment and we're randomly assigning which gas goes in first, which means we can eliminate any potential confounding caused by the order in which the gasolines were put in the tank. So let's check conditions. Since this is a confidence interval, we don't have to write any hypotheses. We skip straight to conditions. Okay, so conditions. We have 2 new ones. First of all, the data are obviously paired up by which car was used. So data are paired by car. And we have to assume that these 10 cars have independent differences. So the difference in the 2 types of gas for this car are independent of the differences for the 2 types of gas in this car are independent of the 2 different types of gas in this car. So we're going to assume each car's differences are independent. There's no link between each of these cars and how they use each type of gas. Okay, so now we get to our usual 3, which is random and the less than 10% and the normality check. So random, we have an element of randomness. This is not a sampling though. This is an experiment. So we did randomly assign the order of the treatments with the tween costs. So treatment order was randomly assigned by a coin toss. So we got our randomness in there. Okay, so then we need our less than 10% condition, except this isn't really a sample. This is an experiment, so instead of less than 10%, I might just argue that each car's fuel economy is independent. Each car's fuel economy is independent. Sounds a whole lot like that second one I checked. This is saying that the differences once you pair them up are, which you can't really have one of these without the other. And last but not least, our normality check. Do we have a nearly normal distribution? Well, we obviously don't have a sample size of 30. We have no idea what the shape is for the population, so we have to look at a picture. We need some differences first, don't we? So let's do some subtracting. How about I do premium minus regular this time, because premium looks like it's bigger most of the time, so I'd have less negative numbers to work with. So I'm going to do premium minus regular. Okay, so difference of 3, difference of 2, difference of 3, difference of 2, difference of 2, difference of 3, difference of -1, difference of 1, 1, and 4. And so doing those differences manually is a lot faster than typing all this individual information in the calculator. Definitely the only way to go. Okay, we have numbers as low as -1 and as high as 4. So maybe count by 2s. And we'll have -2 to 0 to 2 to 4. Okay, so between -2 and 0, we have just 1. Okay, between 0 and 2, we have these 2 1s, so we need that one to be twice as tall. Between 2 and 4, we have 1, 2, 3, 4, 5, 6. Okay, so this one needs to be 3 times taller. So 2, 4, 6. Oops, got that one a little bit fat. And then there's a single 4. Okay, definitely unimodal. It's a little bit skewed left, but not terribly. Definitely no obvious outliers. So this looks better than the last one. So we're going to comment that the histogram of differences is unimodal and not badly skewed. So not too bad. So we're going to say that one's pretty good. We're going to roll with it. So a T-model can be used. Do a paired T interval. Okay, a comment about that last condition check. If you look at the picture, if you look at the histogram, typically on the AP exam they require you to show the histogram. You have to show them a picture of it. Now on this year's exam, that we don't really know yet what that's going to look like. We're going to do some practice items on the AP Central website after we finish this last chapter and start kind of seeing what kinds of things they might throw at us. Honestly, it might be best if you write your work on paper and submit pictures. Even if they do give you an equation editor of some type to type it into the computer, symbols will definitely be easier on paper, easier to draw pictures. I'm not even sure how they would have you draw a picture of this on any kind of technology. And it's because your time crunch is really, really tight, you need to do your work the most efficient way possible. So right now I'm leaning toward probably do it on pencil paper and upload a picture. Okay, now the worst is over. Let's do the mechanics. So the mechanics look just like the mechanics of a one sample T. You start with the mean of your differences. So I need a mean of these differences. Oh, well, I need the calculator to do that. So let's pull out our handy dandy Inspire. And I'm going to call this diffs. And just key these numbers in. 2, 3, 2, 3, 2, 2, 3, -1, 1, 1, and 4. And I always double check, especially on AP exam day, to make sure that my numbers are keyed in correctly, because otherwise everything is off and you have no way of showing what you did wrong. Okay, I'm going to go to a calculator screen because it's just easier to look at and run the procedure. So menu, statistics, number 6, confidence intervals, number 6, and T interval. The paired and the one sample T's both use that same command number 2. We do have data. Choose the data input method. Excuse me. The list I call diffs. You call it whatever you want to. It's your calculator. And the confidence level, this says we want a 90% confidence interval. So I'm going to change that to 0.90, or 0.9 will work, and run the procedure. Okay, So, structure of the confidence interval. You start with your point estimator. So, your mean of your samples, that's 2. Nice, pretty number. Plus or minus T star. Okay, now we're back to not 2 independent samples. And they like for us to show what our T star is if it's based on a single list. So I'm going to just drop down up here at the side. Degrees of freedom is 9 because we have 10 cars. And I'm going to find my degrees of freedom in a separate step. So menu, probability or statistics, distributions is number 5. I need the inverse T command. So a little work off to the side in case we've gotten rusty on this one. Let me actually just throw on a sticky note. So if we want to be 90% confident and we need the upper T-score for that region, then we need 5% in the upper tail, 5% in the lower tail. We need an area of 95% below that T-score. So we're going to use inverse T, give it an area of 0.95. Degrees of freedom are 9. And we get a T star of 1.833-ish. And we're actually going to substitute that one in. The only time that they don't want us to actually write in our T-score is in a 2 independent sample because the formula is hideous and the degrees of freedom are not whole numbers. Okay, we're going to multiply this by the standard error. So that's S over the square root of N. S was 1.414. That looks like square root of 2 right there. 1.414 over the square root of 10. 10 was our sample size. So we have to show what we substituted in, and then we give our final interval. So lower bound of our interval was 1.18 miles per gallon, and 2.82-ish miles per gallon is the upper bound. Okay, ready for a conclusion. We are 90% confident that on average, make sure I squeeze that word in there, average or mean, cars get between 1.18 and 2.82 more miles per gallon with premium gas than regular. So we definitely have evidence that premium does give us better gas mileage. There's another study that remains to be done that's not involved here that's worth, a thought in the real world. Is that extra 1.18 to 2.82 miles per gallon difference worth the 10 extra cents per gallon? So that's another thing to weigh. Sometimes even if it's better, it's still not economically the wisest decision. Okay, that's it. We are finally finished with the last notes. So your day 2 homework for chapter 24 starts on page 648. And we're going to do number 7, 23, 29, and 31. All right. Rejoice. That is the last homework assignment. So all that's left is to take a quiz, review all the T-model stuff, and take our final test over chapters 22 through 24 next week. And then we will start hardcore, going back 1 unit at a time and reviewing stuff that we haven't seen for a while. The plan, if you've looked ahead at my schedule, the plan is to cover a couple of sections a day, a couple of units per day, or a couple days per unit, said that backwards, and make sure that we spend some time on each of the units. And by the time we spend a couple of days per unit and do some practice stuff on AP Central, have some discussions over things that better ways to answer things, what they expect on the AP exam, it's going to be time for the exam. So we are definitely on the home stretch. Do not lose heart. Hang in there just a little bit longer. And we're going to survive it. Okay? See you on review day.